Hello students, welcome to today's session on topic random experiments and events. This is the topic from probability chapter. So we will discuss these terms and we will discuss its application also, and we will see some examples and questions related to this topic. Okay, so let's start the session. So let's understand the first definition. Let's first understand the definition of what are experiments, and then we will cover events. Okay, so first let us understand what is experiment. Okay, so the definition for the experiment, the word experiment means an operation which can produce some well-defined outcomes. Okay, the word, so theory is very important in probability. You must clear your theory, your definition. Okay, so the word experiment means an operation. The word experiment means an operation which can produce some well-defined outcomes. Okay, so we will decode every term. Okay, that is which are going to be very important for this chapter, which are always being used. So outcomes, okay, which can produce some well-defined outcomes. This is important word. Now next, there are two types of experiment. There are two types of experiments. First is deterministic experiments. And the second one is your random or probabilistic experiments. Okay, so by deterministic experiment, we mean that we know what will come. Okay, we are sure. We know what will come. Yes. So what is deterministic experiment? Let's see some example. See, if you are traveling, if you are traveling in a plane or a train, then you know after your train starts from the station, then you know what are the next stations. Okay, you know what are the next station, what are the stations which will come before your final destination. Okay, you all know the stations, you know all your results, your outcomes. That is your deterministic experiment, that you know what will come next. Similarly, if you are traveling in a metro, you know which station will come after that. So that is the case for deterministic experiments. Now, in case of random or probabilistic experiment, that we don't know. Okay, that we don't know. We can only predict, or we can only think of possible outcomes. Okay, so random or probabilistic experiment means if you are tossing a coin. Okay, if you are tossing a coin, so you don't know what you will get. Either you will get head or you will get your tail. Okay, if you are throwing a dice, so you don't know what will come. One will come, two will come, three, four, five, six. Okay, you don't know out of these numbers which number will come as your result, as your outcome. So that experiments are known as random or probabilistic experiments. So I hope you understood this difference between deterministic and random experiments. Okay, so this is the definition for deterministic and random experiments. Now let us see next term. The next term is sample space. Our next term is sample space. So we must be very much crystal clear about these terms, definitions. They are very important. So the set of all possible outcomes of random experiment. Okay, the set of all possible outcomes, the set of all possible outcomes of a which experiment? Random experiment. Random experiment, yes. What is random experiment? That we don't know what will come. That example, tossing a coin, throwing a dice. We don't know which number will come. One will come, or two, three, four. That we don't know. So set of all possible outcomes of a random experiment is called our sample space. Is called the sample. Is called the sample space. Called the sample space associated with it. Associated with it. And it is generally denoted by capital S. This is its denotation. Sample space means this. So this set of all possible outcomes of a random experiment. See, now we will discuss these two examples. If our experiment is tossing a coin, okay, tossing a coin. Now this is my random experiment. So which experiment is this? Random experiment. And in this either I will get head or I will get tail. So if I club this two outcomes in this set curly bracket, so this becomes my sample space of this experiment, this random experiment. Okay, so this is how we create our sample space. Now if I take a rolling a die, okay, so I will get either 1, 2, 3, 4, 5 or 6. If I club all this and put in this curly bracket, then I will get a sample space of all these outcomes. 1, 2, 3, 4. For which experiment? Random experiment. And that experiment is a rolling a die. Clear? Now, if I consider next random experiment of tossing 2 coins. Tossing 2 coins. So if I tossing 2 coins, so either I will get head tail, or tail head, or tail tail. These are the possible outcomes. Okay, so if I club all these outcomes in a curly bracket, and this will measures my sample space. This will give my sample space for which experiment? Tossing of 2 coins. Okay, clear? In this way we can create our sample space. Total outcomes. Now club this in a curly bracket. This will give you the representation of a sample space. Okay. Okay. Now let us do another example. Let us take an example from a group of 2 boys and 3 girls. 2 children are selected. 2 children are selected. Find the sample space associated to this random experiment. Okay, see, from a group of 2 boys and 3 girls. Okay, from a group of 2 boys B1 and B2, and total candidates I have 5, G1, G2 and G3. G1, G2 and G3. 2 children are selected. Okay, find the sample space. Okay, I have to find the sample space. See, So B1 and B2, G1, G2 and G, there are 5 candidates. So I have to select my two candidates like this. This type I have to fill. Okay. So outcome is 10. I know, that's why I fill this graph. So this is your, let us say if I take B1, B2, okay, B1, B2, B1, G1, B1, G1. So position doesn't matter here. You can take G1, B1 also, but you have to select two persons at a time. B1, B2, B1, G1, B1, G2. Okay. Now B1, G2 is there. B1, G3, B1, B2, B1, B1, G1, B1, G2, and B1, G3. B1. Okay. Now done. Now if I take B2, B2 to B1, B2, B1 is already done. Now B2, G1, B2, G2, and B2, G3. Okay. Now G1, G2, G1, G3, and G2, G3. This is your possible outcome for this random experiment. Okay. For this random experiment. Now, if I club all this in a curly bracket, this will make my sample space ready. So this is my sample space. This is how we have to be clear, and it is very important to construct a correct sample space. If your sample space is not correct, then you will get a different values when you're calculating your probability. Okay, so you must be very much clear. Okay, so now let's understand next definition. Next term is event. So our next term is event. So what is the event? A subset of the sample space, a subset of a sample space associated with a random experiment is called an event. Okay. A subset of a sample space. See, we have created a sample space. Okay, we have created our sample space. Let us say we are taking the example of rolling a die. 1, 2, 3, 4, 5, 6. These are the possible outcomes. This is the sample space, clubbing all the outcomes in the curly bracket. So any subset of this is your event. Okay. So if I take A as my getting even numbers, okay, getting even numbers. So this will be your 2, 4, and 6. This is your one event. If I take B, this is your subset. A is your subset of S. So getting odd number, this will 1, 3, 5. This is again your subset. So basically, what is event? Event is a subset of the sample space. Okay. So what is now, if you are taking A union B, if you want to take your A union B means complete A and complete B, the elements are not repeated. So it is your 1, 2, 3, 4, 5. That's it. This is also subset of S. Clear? So this is the definition of event. So event is basically the subset of sample space. Clear? And also one last thing, always probability lies from 0 to 1. Okay. Always probability lies from 0 to 1 because it is probability, it is possibility, not a sure event. And what is the probability of sure event? Probability of sure event is always 1. That is which will happen. Okay. So that's all for today's session. I hope you understood the topic well. If you have any doubt, you can contact me through my Urban Pro Profile app. Till then, revise and we will meet in the next session. Thank you.